Day 37, Honors Physics, Newton's Three Laws, Problem 15. You have a large crate on the floor, weighs 650 newtons with a normal force of 650 newtons. You're trying to push it to get it to move. And sometimes these problems with, when it says like calculate the minimum or the maximum, they can be a little confusing. So I'll explain that a little bit as I go along here. But friction does have a maximum. This is a static friction problem. And the way you calculate the maximum static friction is, well, basically FF, force of friction maximum, is equal to mu times Fn, normal force. So they give you mu here in this problem. We know the normal force, so you can calculate the maximum frictional force. Well, let's plug this in here. 0.35 times 650. So you'll get a value for the force of friction maximum. Equals that number. Okay, whatever that is. So that will then match up to the minimum force that you need to push the block. In other words, if you push harder than that, it'll accelerate because friction can only be that high, static friction. Once it actually starts to move, there'll no longer be static friction. You'll switch to kinetic friction, which is actually even less than, typically, than the static friction. But just a couple of other comments on this. For example, that number is going to be probably in the 200s somewhere. But like if I push this block with 50 newtons of force, and it doesn't move, because it won't, because friction can have a maximum of 200 and something here, static friction. So if I push with 50, friction would be 50. It wouldn't be its max. Okay, it'll match me until its maximum. If I push with 100 and friction can be 200, it'll only be 100. It'll only match me until we get to the maximum. Then it cannot match me anymore. Then the block will, in a sense, break loose and start to accelerate, and then we'd have to recalculate the kinetic friction, and then we could calculate the acceleration according to F net equals ma.